Good morning, class. Today we're going to be working on ratio word problems. But first, we're going to go back and review and look at the basics. So what is a ratio? Type me a little definition. So ratio is a way to describe a relationship between two numbers. So let's take a look at that. So if there are 12 boys and 16 girls, the class ratio of boys to girls is 12 to 16. Okay, so that one we put 12 to 16. But how many different ways can we write ratios? So I have 12 to 16, so you can write 12 to 16. You can write it as a fraction. This doesn't really look like the normal fractions that we would write because I have to type it. But you can write it as a fraction, so it would be 12 over 16. You can write it as a decimal. So I just took 12 and divided it by 16 in my calculator and got 0.75. And you can also write it with a colon. So 12, that little colon is like saying 2, 16. But also there's a couple more ways. You can reduce, and you should reduce most of the time, depending on what the question is asking you or how you're answering it. So if you reduce 12 and 16, you can do 3 to 4, 3/4, or 3 to 4, 3:4. 0.75 would be the same either way. So some important things to remember. Most of the time, you will want to reduce. Oops. When you are expressing a ratio, the order that it is stated is the same as the order that it's presented. So right here, it said if there are 12 boys and 16 girls in the class, the ratio of boys to girls is 12 to 16. So if I have boys to girls, if we have boys to girls, then we're going to put the 12 first because the number 12 corresponds to the number of boys. We're going to put girls or the number 16 second. Okay? So 12 to 16. So this corresponds to this, and this corresponds to this. Here, let's get some color in there. So this one goes with this one, and this one goes with this one. Okay. So one other thing is, so we can put it into a fraction or we can put it into a decimal, but you do not want to express ratios as mixed numbers. You don't want to express them as mixed numbers. So you don't want 1.75. You don't want, so let's say if we did a ratio right here of girls to boys. Here, I'm going to erase this. If we did girls to boys, that would be 16 to 12. So I can reduce this down to 4 over 3, but I don't want to reduce it far enough that I'm saying 1 1/3, because then we kind of lose sight of what the ratio is representing. So you need to keep it as an improper fraction or Yeah, keep it as an improper fraction at that point, or keep it as like something with a colon or something with 2. Don't do this. This is bad. Okay. So, also with ratios, there's usually 3 different numbers involved, but only 2 of them are used in each ratio. So most of the time you can talk about there's like 2 different parts that they're comparing, and then there's a whole. So you have to be very careful and think through, what are they asking me? What are we doing? What are we talking about? So my tips for how to navigate these. So if we're doing the problem, the team won 4/7 of the game and lost the rest. What was the win-loss ratio? Okay, so what do we know right now? Okay, so we were given 4/7, and the problem said the team won 4/7 of its games and lost the rest. So if they won 4/7, I'm going to guess that 4/7 represents how many wins to how many losses. Okay, so we have, or no, not how many wins to how many losses, how many wins to how many total games. So we have 4 wins and we have 7 games. Okay. So first I'm going to identify the given ratio. So what am I already working with? Okay. Now I need to calculate the missing number. So what we need to do here is it's asking us for a win-loss ratio. We don't know the number of losses, but we can calculate the number of losses. If they played 7 total games and they won 4 games, that means that they lost. They have 3 games that they lost. Okay, so we take our total number of games that we already know, subtract our wins, and that means that they lost 3 games. Okay, so now we need to figure out what our new ratio needs to be. So what is the problem asking us? Okay, and today or this week when we're working on word problems, it's really important to ask that question. What is the question actually asking me? What am I trying to figure out? So we're trying to figure out the win-loss ratio, okay? So I have here, if I'm doing a really good job of labeling when I'm doing my work, I know that we have 4 wins and we have 3 losses. So my ratio is 4:3. Okay. This is kind of just a bonus review. I don't think we'll use this for our word problems, but it was a question that a lot of you had on the last work, written practice. That's what they're called. So another place we use probability a lot of times is to find probability, or to write probability. So the probability of an event is equal to the number of favorable outcomes over the total number of possible outcomes. So the number of favorable outcomes, that's the top bar, over the total number of possible outcomes. The total number of possible outcomes, okay? So those are our 2 things that we are comparing. So one thing that is important is we need to figure out the sample space to figure out the number of possible outcomes. So to figure out this yellow part that I highlighted, we have to find the sample space. Okay. I don't know what I put down here. We're going to erase and find out. Oh, yep. Okay. So a couple examples of sample space. So if you're flipping a coin, the possible outcomes are heads or tails. If you're rolling a 6-sided die, you can roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay, these are your sample spaces. These are the possible outcomes. So if I was looking at the probability of rolling a 1. There's only one chance that I can roll a 1, correct? And then how many total possible outcomes? How big is our sample space? This is our sample space. So how many chances are there? There's 1, 2, 3, 4, 5, 6. So the probability of me rolling a 1 is 1/6, because this is the number of favorable outcomes, so I want to roll a 1. Out of 6, there's 6 possible outcomes of rolling a die. Okay? So a lot of times you guys maybe have used, and I've seen on some of your homework, I'm making a little tree to try to figure out the sample space. That's great. So what those look like, I kind of already wrote some of the stuff out here. But you do your heads. So this is if we're rolling or spinning a force 1, 2, 3, 4 spinner and doing a coin flip at the same time. So this is to try to figure out the sample space of that. So you would start with one of your variables, so that's like the head or tail flip. You're going to write those out. And then if I get heads, then I can still spin the spinner and I can get a 1, a 2, a 3, a 4. Okay. So then if you do the same thing, so we map those out. So this is like I rolled a heads, I got a 1. I rolled a heads, or I flipped a heads, got a 2. Flipped a head, got a 3. Flipped heads, got a 4. So you can make these little trees. And sometimes, depending on how many different moving parts you have, you might have a big, huge tree. So if you were trying to figure out what color socks, shirt, and shorts am I going to wear today, and you had like 4 different options, that could be a really big tree. We could do the sample space for that. But so right here, our sample space is H1, H2, H3, H4, T1, T2, T3, and T4. So there's 8 different options that could occur in this experiment. How are we doing on time? Okay, we're at like about 12 minutes here, so I'm probably going to lose your attention. So I think we're going to take a deep dive into ratio word problems tomorrow. I'm going to give you some ratio practice for today just to brush up. I guess if you are feeling very bold, you can get started on the ratio word problems practice set as well. But I'm going to post a practice set for you guys to work on. Great. Have a good day. If you have questions, stop by office hours. We can do some sample spaces on a whiteboard, or we can work with some ratios or find some problems. If you want help, I'm happy to help you. Swing into office hours. Bring a buddy if you want. Text him and be like, I'm going on at this time to ask this problem. Do you want to come? It's just more fun when there's more people. I think that's all. Have a great day.